Before we begin, make sure you subscribe and turn on notifications because the universe doesn't send reminders before it changes forever, and the next discovery could happen at any time. Somewhere in our galaxy, a massive star is dying. It is unstable, it is unpredictable, and astronomers believe it could explode at any time. When it does, it will outshine entire galaxies. It will briefly become one of the brightest objects in our sky. And depending on how it dies, it could unleash more energy in a few seconds than our sun will produce in its entire lifetime. Meet Betelgeuse, the red giant on the edge. The star at the center of this concern is Betelgeuse. Located roughly 640 light-years from Earth in the constellation Orion, Betelgeuse is a red supergiant nearing the end of its life. It is enormous, so large that if placed at the center of our solar system, and its outer layers would extend past the orbit of Mars, possibly even reaching Jupiter. Unlike our Sun, which is a stable, middle-aged star, Betelgeuse has already burned through much of its nuclear fuel. Stars live by fusing lighter elements into heavier ones in their cores. When hydrogen runs low, fusion shifts to heavier elements like helium, carbon, oxygen, and eventually silicon. Each stage burns faster than the last. Hydrogen fusion can last billions of years. Silicon fusion lasts days. Yet when a massive star reaches the end of this chain, there is no further fuel to support fusion. Gravity wins, the core collapses, and the star explodes in a supernova. Betelgeuse is approaching that final stage, but approaching in astronomical terms can mean tomorrow, or 100,000 years from now. That uncertainty is what fuels both fascination and fear. The Great Dimming, a warning sign? In late 2019, Betelgeuse did something strange. It dimmed, not slightly, dramatically. The star's brightness dropped to levels never recorded in modern observation. For months, astronomers watched closely, wondering if they were witnessing the final moments before a supernova. Social media exploded with speculation. Headlines warned that Betelgeuse might go supernova soon, but it didn't. Instead, researchers later determined that a massive cloud of dust, likely ejected from the star's surface, temporarily blocked some of its light. Betelgeuse eventually brightened again. Still, the event revealed something critical. Betelgeuse is unstable. Its outer layers pulse and convect violently. Giant plumes of hot gas rise and fall. The star loses mass constantly, shedding material into space. It is not a calm, predictable body. It is a star in its final chaotic chapter. And when massive stars become unstable, they don't fade quietly. They explode. What happens when a star like Betelgeuse dies? When a star more than 8 times the mass of our Sun exhausts its nuclear fuel, the core collapses under gravity in less than a second. This collapse triggers a shock wave that tears through the star's outer layers. The explosion, a core collapse supernova, releases an enormous burst of energy. For a few weeks, the supernova can shine brighter than all the stars in its host galaxy combined. If Betelgeuse explodes, it will become visible even during the day. At night, it could rival the brightness of the full moon. The explosion would also produce a flood of neutrinos, nearly massless particles that pass through matter almost undisturbed. Earth's detectors would pick them up hours before the visible light reaches us, giving scientists a brief warning. But beyond the spectacle, there is the question of danger. Would Earth be affected? Distance matters. Betelgeuse is approximately 640 light-years away. That distance is critical. A supernova can be dangerous if it occurs within about 50 light-years of Earth. At that proximity, high-energy radiation and gamma rays could damage Earth's ozone layer, potentially increasing radiation at the surface and affecting life. But Betelgeuse is more than 10 times farther than that danger zone. At its distance, the explosion would be a breathtaking cosmic event, but not a catastrophic one. We would see it, we would measure it, we would study it, but we would not be destroyed by it. Gamma-ray bursts, the real threat? Some of the most dangerous stellar explosions are not ordinary supernovae, but gamma-ray bursts. In rare cases, when a massive star collapses, it can produce narrow beams of intense gamma radiation. If one of those beams were pointed directly at Earth from a close enough distance, it could have severe biological consequences. However, Betelgeuse is not expected to produce a long-duration gamma-ray burst aimed at us. Its rotational characteristics and likely explosion geometry make that scenario highly unlikely. Even if it did produce high-energy radiation, its distance greatly reduces the risk. Astronomers have carefully evaluated the threat. The conclusion is reassuring. Spectacular? Yes. Dangerous? No. The timing problem. One of the biggest misconceptions about Betelgeuse is the phrase, "any minute." In stellar terms, Betelgeuse is indeed near the end of its life. But that end could still be tens of thousands of years away. Astronomers estimate that the star is likely in the late stages of nuclear fusion, but predicting the exact moment of core collapse is nearly impossible. We know it will explode. We just don't know when. It could happen tonight. It could happen long after human civilization is gone. The universe does not operate on our schedules. What we would see, if Betelgeuse explodes, the event would unfold in stages. First, neutrino detectors on Earth would register a sudden burst. These particles would reach us hours before visible light. Then, the star would brighten dramatically over days. Orion's familiar shape would change. The red shoulder of the constellation would flare into a brilliant white-blue light. For weeks, perhaps months, it would dominate the night sky. Eventually, the light would fade. In its place, a glowing nebula would expand slowly over thousands of years, enriching space with heavy elements. Supernovae are not just destructive, they are creative. The iron in your blood, the calcium in your bones, the gold in jewelry, all were forged in ancient stellar explosions. When Betelgeuse dies, it will scatter new elements into the galaxy. Destruction and creation are intertwined in cosmic evolution. Are there other stars we should fear? Betelgeuse often headlines discussions about dangerous stars because it is nearby and visible to the naked eye. But there are other massive stars in our galaxy. Fortunately, most potentially hazardous stars are located thousands of light years away. The vast distances of space act as natural shields. Even though supernovae release staggering amounts of energy, that energy disperses across enormous volumes of space. The Milky Way is about 100,000 light-years across. On that scale, 640 light-years is relatively close, but still far enough to keep us safe. Our cosmic neighborhood is surprisingly calm. Why this matters? Even if Betelgeuse poses no threat, studying it is invaluable. A nearby supernova would provide astronomers with unprecedented data. We could observe the entire explosion in detail, measure neutrino emissions, analyze shockwave dynamics, and refine models of stellar evolution. It would be the most important astronomical event of the century. Understanding how massive stars die helps us understand how galaxies evolve. Supernova seed space with heavy elements can trigger new star formation and influence cosmic chemistry. Betelgeuse is not just a potential explosion, it is a laboratory waiting to happen. The internal clock. What's happening inside Betelgeuse right now? To understand how dangerous Betelgeuse really is, we have to go deeper. Inside the star itself. Betelgeuse is not burning hydrogen like our Sun. It moved past that phase long ago. In massive stars, nuclear fusion happens in layers, almost like an onion. At the center, the heaviest elements fuse. Surrounding that core are shells where lighter elements continue burning. Right now, Betelgeuse is believed to be fusing heavier elements in its core. The exact stage is still debated among astronomers. Some models suggest it is burning carbon. Others propose it may already be in a later stage, such as neon or oxygen burning. Each stage happens faster than the one before it. Hydrogen fusion lasts millions to billions of years. Carbon fusion lasts thousands of years. And silicon fusion, the final stage before collapse, can last only days. Once silicon fusion begins, the clock accelerates dramatically. The core rapidly builds up iron, and iron is the end of the line. Unlike lighter elements, iron does not release energy when fused. It absorbs energy. When the core becomes iron-rich, fusion can no longer support the star against gravity. The core collapses in a fraction of a second. The outer layers then rebound outward in a supernova explosion. The challenge is this: we cannot directly see Betelgeuse's core. We rely on models, surface behavior, and indirect measurements. That makes timing extraordinarily uncertain. It could explode soon in cosmic terms, or it could still have thousands of years remaining. The size problem: a star too big to stay stable. Betelgeuse is not just massive in weight, it is enormous in size. It has expanded to hundreds of times the radius of our Sun. This expansion is a consequence of its internal instability. As fusion progresses through heavier elements, energy transport inside the star becomes turbulent. Convection cells larger than Earth rise and fall through its outer layers. These convection cells are so massive that astronomers have imaged surface features, giant bubbling regions on the star itself. This instability is critical. Massive stars near the end of their lives experience violent pulsations. When their outer layers expand and contract, gas is expelled into space in enormous quantities. Betelgeuse is losing mass continuously, shedding material into a growing envelope around it. In fact, Betelgeuse has already created a vast bow shock in interstellar space as it moves through the galaxy, pushing expelled material ahead of it like a cosmic wake. This mass loss affects how the star will die. The more mass it sheds, the less fuel remains in its core, and that influences the type of supernova it will produce. Betelgeuse is unstable, but instability does not equal immediate explosion. Could it already have exploded? Here's where things get mind-bending. Betelgeuse is about 640 light-years away. That means the light we see from it tonight left the star around the 14th century. If Betelgeuse exploded 100 years ago, we wouldn't know yet. The light simply hasn't reached us. In theory, the explosion could have already happened. We are always looking into the past when we observe distant stars. The universe is not seen in real time. However, based on current models of Betelgeuse's internal stage, astronomers believe it is unlikely that the star has already undergone core collapse. Surface data suggests it is not yet in the final silicon burning phase. But unlikely does not mean impossible. That uncertainty is part of what makes Betelgeuse so captivating. What would happen to Earth's sky if Betelgeuse explodes? The night sky will change dramatically. Orion is one of the most recognizable constellations in the world. Betelgeuse forms the bright red shoulder of the hunter. When it explodes, that shoulder will transform into an intensely bright point of light. At peak brightness, the supernova could rival the full moon. It might cast shadows at night. It could even be visible in daylight for weeks. Over months, it would slowly fade. Eventually, it would leave behind a nebula, an expanding cloud of gas glowing faintly for thousands of years. Future civilizations might look at that nebula and remember the night the sky changed, astronomers would gain an unprecedented opportunity. We have not witnessed a nearby supernova in the age of advanced instrumentation. Modern telescopes, neutrino detectors, and gravitational wave observatories would capture every stage of the event. It would be a once-in-a-lifetime scientific treasure. The neutrino warning. One of the most fascinating aspects of a supernova is the neutrino burst. When the core collapses, it releases an enormous number of neutrinos, nearly massless particles that interact very weakly with matter. These neutrinos escape the collapsing core immediately and travel at nearly the speed of light. Because light from the explosion takes time to emerge from the star's outer layers, neutrinos reach Earth hours before we see the bright flash. That means detectors on Earth would register a sudden neutrino surge, effectively warning astronomers that the visible explosion is imminent. It would be the first time in history that humanity receives a cosmic alert that a star has just died. The supernova remnant, what comes after. When Betelgeuse explodes, it will not disappear completely. The core that collapses may become either a neutron star or possibly a black hole, depending on its final mass. Current estimates suggest it is more likely to leave behind a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. The outer layers of the star will be blown into space at tremendous speed, enriching the surrounding region with heavy elements. Supernova remnants are not just debris fields. They are seeds of creation. The shock waves from such explosions can compress nearby gas clouds, triggering the birth of new stars. In this way, one star's death can initiate the formation of others. The universe recycles itself constantly. The real dangers in the galaxy. While Betelgeuse captures headlines, it is not the most dangerous possible stellar event. The true cosmic threats are rare gamma-ray bursts aimed directly at Earth from relatively close distances. Such an event could potentially damage the ozone layer and affect life. But those events are extraordinarily rare in our region of the galaxy. Astronomers continuously monitor nearby massive stars. None currently pose an imminent existential threat. The Milky Way contains hundreds of billions of stars. The vast distances between them act as protection. In cosmic terms, Earth resides in a relatively quiet neighborhood. Why this story captivates us? So if Betelgeuse is unlikely to harm us, why does the idea of its explosion grip the imagination? Because it reminds us that the universe is alive with change. Stars are not permanent fixtures. They evolve. They swell. They collapse. They explode. Human civilization has existed for only a fraction of the time Betelgeuse has been shining. Watching it die would connect us directly to cosmic timescales. It would be a reminder that the elements that make up our world were forged in ancient stellar explosions. When we look at Betelgeuse, we are looking at a future supernova. And when it explodes, and it will not be a symbol of destruction for Earth, it will be a symbol of the universe in motion. So, should we be worried? The honest answer remains no. Betelgeuse is fascinating and unstable. It will eventually explode. But it is too far away to threaten life on Earth. When it dies, it will light up our sky and advance science dramatically. The real danger is not Betelgeuse. The real danger is misunderstanding scale. The universe is violent in places, but it is also vast beyond comprehension. The distance is our shield. When Betelgeuse finally goes supernova, whether tomorrow or 10,000 years from now, it will not be a disaster. It will be a cosmic spectacle, and humanity will be watching.